So in the previous video we set up player controls so we can move our player cube around. In this video we'll set up the networking so that we can open up another tab and we'll be able to see another player in the environment. So if we go to our main file, okay, so to add networking we will need to set up a Firebase. So go to firebase.com and we'll use their new interface and you get started for free. And we'll create a new project. I'm going to call this one multiplayer template 1. Create project. And we're in our project now. I'll click on database on the side here. Dismiss this. Okay, so we've set up our project for Firebase. Now we can start using it. But before we can use it, in our project we'll need to reference the Firebase JavaScript library, and in our game.js file we'll set a reference to our project. So new Firebase, and within the quotations we copy our project path, including the HTTPS and the rest of this content. And I'm going to add data to the end of that because it will have something like this. We'll have our data be placed in the value, and we'll have the data field. Next step in our networking process, we should have a player ID for this particular player. And instead of having this content here, we'll place it in another function, and we'll call that init main player. And we'll initialize the player here and call this function. Okay, now let's give the player an ID instead of having 1 as the default, because all our players, we don't want them to have an ID of 1. So player ID, pass it here, and it's referencing this player ID. So this code says that we're taking our Firebase reference and we're accessing a child called players, and we're pushing to it some data, and then we're retrieving the key for that data. And then that key that we pushed, the value of that key is going to go into the player ID field. So every time data is pushed to a location in the Firebase database, it's going to be unique. And so this is a way of generating a unique player ID, and then we're just passing it to the player that we create here. So next we will just initialize some data into the specific this player's location. So here we're taking the Firebase reference and we're accessing the child called players, and then a child within that field called player ID, and then orientation, and we're setting this data, the orientation data, to have a field of position and rotation, and the X, Y, and Z to be 0. Same for the rotation. So let's go ahead and run this to see what I'm talking about. If I refresh here and open the console to make sure there are no errors. Okay, there seems to be a problem. Oh, I don't have permission apparently. So to have permission, we see here data, and here are rules, so we click on the rules, and apparently by default now Firebase applications require the user to be authenticated, so auth cannot be null. So instead we'll replace that with true, so we can read and write without having to authenticate. And this causes security concerns, but we'll worry about those security issues in the next episode of this tutorial. So we'll publish this, our rules are saved, and if we refresh, we should be fine now. So let's go back to our data, and we see here we have data as a child of our main Firebase, the root Firebase, and this is the ID of the player that we just created. And there's a child called the orientation and position, and these should be all set to 0. And that's the effect of the code that we just wrote. And if I refresh the page, we should have another child. Another child is created, another ID, same position, rotation, orientation fields. Okay, that's great. But actually, when we leave the page, we want this data to be deleted. So we'll do this. We'll on window unload, we'll call this function. So here we're setting this function, this attribute of the window on unload to a function. So when the window is unloaded, or when the player leaves this tab, then we have our Firebase reference to this specific player ID, and we're just removing it. So basically we're deleting that field. So let's go ahead and remove our current data, and there's a warning there. So we deleted the data. Our code is not saved yet, so we'll save that, Control S, and refresh the page, and that creates a field here. And if we go back, for instance, our data is deleted. That's great. So now we need a way to update the player's position when they are moving around. So for instance, let's put these side by side. The database and our game view. So right now when the player is moving, nothing is happening over here, so it thinks this player is still at position 0, 0, 0, and the rotation 0, 0, 0. So let's add some code to change that so that this data is updated to the player's current orientation. So in order to do that, let's open up the player controls file in the lib folder. If we scroll down, there should be a function called check key states. This function checks the keys that the user is pressing, and at the end of the function, we're going to update the player's orientation data to our Firebase. So here, taking the Firebase reference, the child players, the player ID, orientation, and we're updating it. We're updating the position to have this information, the X to have this player dot position dot X, and the player's Y position, Z position, and we'll update the rotation as well. If we save this, this should work. So if we refresh the page now, and notice how it deleted the data, that's great. Let's go ahead and expand these again. Okay, so now if we move around, if I go back and forth for instance, the data is updating in real time. And that's great. That's exactly what we wanted. So now we have a way, now we have an interface sort of between our clients. So this is one client, and then if my friend is on his computer on the other side of the planet, then this server can serve the data to his computer directly, and that's how we will achieve this multiplayer aspect. So what happens when another player joins our session, the game? So let's see what happens. So we see that their ID is added here, and their data updates. But we can't see them still. So we need to do a few things. We need to listen to other players being added to the Firebase data, the Firebase database. So let's see. If we go back to our code here, we need a way to listen to other players. So that's exactly what we'll write. We'll have a function called listen to other players. And so here we're going to listen to when a player is added, do something, and when a player is removed, we want to do something. Okay, first let's consider when a player is added to the database. So when a player is added, we can listen to that with this code. So here we're listening to the players field, and on child added we have this callback function that will be called whenever a child is added to this field. So let's check that to make sure that the player data exists. So if the player data exists, let's make sure that the player ID does not equal this the child that's added. So this is the key. This is the player ID for the person who's just added. And let's make sure that that person's ID is not this current person's ID, or else we would be adding our player sort of twice onto the scene. So we'll have that there. And in order to keep track of all our players, let's have a sort of dictionary, other players, that will have the key. The key value will be the player's ID, and the value will be the player, an instance of the player. So let's also condition this to be, and other players, and they can't exist in our current dictionary. So that's the other condition we'll have for that. So when a player is added to the database, we want to do a few things. We want to instantiate them, as we did for our player over here. So we instantiated this player object and set it into the player, and then we initialize the player. So we want to do the same thing for other players. So we take the other players dictionary. We add this key value pair. So the key is going to be the player ID. This data references the ID of the player that was just added to the game, and then we'll pass the same ID here, same data, and then we'll instantiate, and we stored this player in this object, and then we'll instantiate it just by calling init. And then we also want to listen to when the player moves. So at the end of this, we'll add this on value. We'll listen to the player, and we haven't created this function yet, so we'll go ahead and do that. So function listen to player, and it'll take in the player data. So this is a callback function that takes in player data. And it's not going to be the same player data here, it's going to be a different player data. I hope that's not confusing. Okay, so let's see. We want the player data to exist. So if the player data exists, we want to call this function in player. It's called set orientation here, and we'll pass in the position. So player data.value.orientation.position and orientation.rotation here, and that will be processed here, and that will allow us to see the other player move. So let's see. Yeah, this current code should work for just watching the player move. Let's refresh to see. So it looks like it's not working as expected. Okay, let's go to the code and see listen to other players. Right, we didn't call this function, so we need to go ahead and call that here. Okay, so let's refresh now. Oops, wrong one. Okay, so we see the other player, and of course we refreshed the page and the other player didn't disappear because we haven't taken care of that. Okay, but this works. This is great. We can see the other player. Now we'll handle the case when a player leaves. So we just handled the case where the player, a child is added to this player field. Now we want to handle the case when a child is removed, and that code is as straightforward. So instead of child added, we have child removed. And so when a child is removed, we want to do a few things. We want to stop listening to what they're doing, and we want to remove them from the scene, and then we also want to delete their key value pair from our dictionary here. And removing them from the scene is the important part if we want to remove them, like if we don't want to see their physical representation. but the other parts are equally as important. So we have this code. So this first line, if I can maximize this, we, instead of on, we have off. So we stop listening to this data location, and we stop, and we need to pass in the callback function that we passed in when we were listening to it. And then we remove that player's mesh. This is important. The player's mesh from the scene. And don't forget, you can pause this at any time if I'm going too fast. And we will delete their key value pair from our dictionary with this line. So let's go ahead and delete our current data. Refresh the page. And nice, we see the player. Now the part we just coded is we shouldn't see the player if we leave. There we go. And if we join again, there we go. We can have people enter and leave, and it updates across the entire network. So hopefully that was useful to you in some way. And in the next video, we will be discussing security. And that's a really large topic. So we'll discuss some ways on how to prevent people from cheating in your game. So apparently our rotation isn't going through, so when we're rotating across the y-axis, it's not being delivered, but our position is. So to fix this, we can go to players, and rather than having this rotation copy, we can go to X and set that to as so. Rotation Z, just like that. And if we refresh, let's see. There we go. So that should work. Alright, so in the next video we'll be discussing security. So as for now, our application is not secure at all. Anyone can access, read and write our data. So security is a really big thing, and I'd like to discuss it, how to make your application more safe to prevent things like cheating in your game. So for example, right now you could go to your console and call the load game function again, and you have a completely new player, and the old player exists, and it just messes up your plans on keeping the game really nice. Alright, see you in the next video. Thanks for watching.